All right, homework C. So, question 1. So in this question, we have, this is essentially an international trade question. So the first part, we have a time before we had international trade barriers. The Ministry of Magic eventually lifted the trade barriers, which gave us a global price of 12 galleons. So we also had a 1 galleon import tax. And so what we're trying to do is figure out what happened after the tariff was imposed. So we're just going to go through, we're going to first solve for the international trade equilibrium, and then we're going to impose a 1 galleon tariff on imports. There's not really enough space to answer it here, so what I'm going to do is do this on a separate piece of paper. Okay, so let's just go through this. Call this question 1. Okay, so the first part, so the ministry had fully lifted trade barriers to imports and exports. So the first thing we have to do is actually figure out whether we're importing or exporting. And to do this, we have to solve for the domestic equilibrium price. So to do this, we're just going to, set up our graph. Okay, so on the vertical axis we have price, horizontal axis we have quantity, and let's set up our two curves. The first one is the supply curve, second is the demand curve, and we want to find this point. This is 17 and 2. We won't actually need these intercepts, but it's nice to know sort of intuitively where they are. All right, so let's find the domestic equilibrium price. Domestic price. All right, so I'm going to find P star. And the way we do this, so you could invert these functions if you like, but what I'm going to do is just solve for equilibrium quantity first. And then we'll use the quantity to find the price. So we'll set the two prices equal to each other, which gives us 17 minus 1 over 6q is equal to 2 plus 2 over 3q. And then from here, we're just going to solve for q. So this is 15. And then on the other side, we have 1 6 plus, so this is actually 4 sixths, and that's all multiplied by q. So here, this thing is equal to 5 over 6q. All right, so this is turns out to be kind of a nice number. We get q. We multiply both sides by 6 over 5, so that comes out to be 18. It's 15 divided by 3 multiplied by 6. So this is 16. Then we need to find the price. So the easiest way to do this, in my mind, would be to plug it into the supply curve. So just do that. But of course, you could plug it into the demand curve if you like. So this is 2 over 3 times 18. And so we have 2 plus 18 divided by 3, which is 6, and then we multiply by 2, is 12. So equilibrium price is 14. Now we're given that the global price is 12 galleons, so let's just plot that. So we have an equilibrium price of 14, and the global price is below. I'm going to draw this in a slightly exaggerated way. So we have PG is equal to 12. Okay, so we know before we impose the import tariff, we have imports. So the quantity demanded globally, QB, is much larger than the quantity supplied. Okay, so then this difference here is our imports. Nice. So the question is asking sort of what happened to this market after we imposed the tariffs. And often we're not going to have fully specified questions. And part of what this question is asking us is to use our sort of economics tool set applied to this problem. So we're not simply looking for any particular value. We're trying to understand what's going on sort of comprehensively. So one thing we might want to try to understand is what was going on before we imposed the 1 galleon import tariff. So let's just write this out as pre-tax. So what we're going to do is use our price of 12 and solve for these two quantities, and that'll allow us to find the imports. So the quantity demanded, we'll use the demand curve. So we plug in a price of 12 into the demand curve, which gives us this thing. And then we solve for QB. So this is 16 QB is equal to 5. And then we have QB is equal to 60. Whoops, this is equal to 30. 6 times 5 is equal to 30. Nice. All right, so then for the supply curve, we're just going to do the same thing. So we have a price of 12. Plug that in. We get 2 plus 2 over 3 QS. And then this is 10 is equal to 2 over 3 QS. So then QS is equal to 30. So it's 10 times 3 divided by 2. So that's 30 divided by 2 is 15. Okay, so this thing is equal to 15. This thing is equal to 30. So our imports are equal to 15. Nice. And we could go through and, solve for welfare measures as we like. Okay. So another thing we might do is talk about the import tariff. And what we're doing with an import tariff is, let's do this maybe in pink. So an import tariff is effectively raising the price you have to pay domestically for international goods. So here we have an import tariff of 1 galleon, so we'll call this P tau, which means the domestic price that you pay for an international good is now 1 galleon higher than the global price. In this case is 12. So let's write this out. So we want to find the post-tariff quantity demanded and the post-tariff quantity supplied. And then we'll just solve for these things. So we call this post-tariff. So we have, so we're just like we did with the pre-tariff. We're using the price that you're facing domestically with the supply and demand curves. So we have 13 is equal to 17 minus 1 over 6 QB. And then we'll just solve this thing out. So this is 1 over 6 QB is equal to 4. Then QB is equal to 6 times 4, which is 24. Mental math, Okay. So then what we want to do next is find the quantity supplied. So we do the same thing with the supply curve. So we have 13 is equal to 2 plus 2 over 3 cube. Oh, this is a mistake. This should say QS. You've probably already realized that. Okay, so this is QS, and then we'll just solve this thing out. So this is 11, 2 over 6 QS. So this is going to be a fraction. So this is, hold on, 2 over 3. So this is 33 over 2 is our QS. Okay, so the next thing is so we'll just plot this first. So we have QB this is QS with the tax is equal to 24. No, doing this wrong. QS is equal to 33 over 2. And then our QB with the tax is equal to 24. So then imports after the tax have gotten smaller. So imports after the tax is the difference between these two things. So it's 24 minus 33 over 2. And you can plug this into a calculator as you like, but what I'd get is 15 over 2. Okay, so then maybe another thing we might care about here is deadweight loss. So we've imposed a tariff and we wonder what's happening to our welfare. We could go through and calculate all of these things. I'm not going to do that here. So the deadweight loss in this environment is, well, let's actually write out these areas. So we have A, we have B, we have C, D, E, F, G, and H. So let's do some welfare. So consumer surplus domestically is A plus, well, just A. Everything below the demand curve, above the price, and inside the quantity. Producer surplus is B plus D plus H. And nothing else. So we don't have any government revenue. We don't have any deadweight loss. In this environment, we're simply looking at sort of comparing it sort of without the international trade. With the tax, before we impose the tax, our consumer surplus is equal. So it's everything below the demand curve, above the price that we're paying, which once we've opened the domestic market to international trade is this 12, and then inside the quantity that's bought. So that's A plus B plus C plus D plus A plus C plus D plus E plus F plus G. Okay, and then producer surplus, these are going to be the only two measures before we impose the tariff. Producer surplus is simply H. So you can see we've generated E plus C plus F plus G simply by opening the domestic market to international trade. One of the conclusions here, though, is that we've eliminated a lot of producer surplus. So B plus D has been transferred from producer surplus domestically to consumers when we've opened the domestic market to international trade. But let's look post-tariff. So we have consumer surplus, which is everything below the demand curve, above the price, inside the quantity bought. So this is A plus B plus C. Producer surplus is above the supply curve, below the price, and inside the quantity sold. So this is D plus H. We have government revenue, which is coming from the import tariff, which is the number of imports. So it's going to be above this interval, and then between the two prices. So that's just H. Oops, I'm sorry, that's F. And then what we don't have in any of these measures is E or G. So our deadweight loss is E plus G. All right, so this is our welfare analysis using an international, in international trade using an import tariff. Okay, so maybe we'll leave this here, but there's more we could do. Like we could calculate the deadweight loss. And let me just actually write out what the value of the deadweight loss is. We'll leave the calculations for later. But so the actual calculation for the deadweight loss is the height, which is the height of both of these things times the base of both of these things. So this is, so first for E, this is, so it's 1/2 times height, which is just the 1, times the base, which is the difference between 33/2 minus 15. Then we have to go to this one, so we have to add up what G is. So again, this is 1/2, it's a triangle, times 1, which is the height of the tariff, multiplied by the difference between 30 and 24. So that's just 30 minus 24 is 6. Okay, so then you could plug this into a calculator if you like, but that's sort of how we would actually go about calculating the deadweight loss. All right, very nice. So then the second question is about a tax. So let's see, why don't we try to do that here? Let's do this in blue. Question 2. So maybe we'll label these things. So butterbeer, and then we'll label this too. So this is lemon tarts. Okay. So butterbeer. So wars are very expensive, and the Ministry of Magic was facing some financial trouble, so they decided to impose a tax of 2 galleons on the sale of butterbeer as a source of funding for the ministry. So we have the supply and demand curves for butterbeer given by these two things, and then what we're asked to do is use a graph and algebra to calculate the equilibrium before and after tax. So we start with the equilibrium, pre-tax equilibrium, then solve for equilibrium quantity and the two prices. Okay, so then we conclude with the relevant components. All right, so what we're going to focus on is sort of considering, so we're going to start with the beginning, before the tax, then we'll move on to the post-tax, and then we'll consider sort of how welfare has changed. Okay, so let's just set up a little graph. So on the vertical, we have price. Horizontal, we have quantity. Our supply curve looks like this. Horizontal at 2, or sorry, vertical at 2. We have downward sloping demand curve. Vertical intercept of 20. So our initial equilibrium happens here. And then we'll talk about the tax once we get there. So pre-tax, we want to find the equilibrium. So as we always do, we set price equal to itself. So the price of the buyer is equal to the price for the seller. So this is PS is equal to PB. And we set these two things equal to each other. So this is 20 minus 1/2 Q is equal to 2 plus 1/2 Q. And then we solve for Q. So this is 18 is equal to Q. Turns out very easy to solve. All right, so our equilibrium quantity before tax, put a star on this, is 18. I'm not going to write it in here. Okay, and then our equilibrium price, we just take this quantity and plug it into the supply curve. So this is P is equal to 2 plus 1/2 times Q. And Q in this case is 18, so our P star is equal to 11. All right, and then we'll just put a P star here. This thing's equal to 11, and we've just denoted that here. All right. So the next thing we'll do is calculate the post-tax equilibrium. And just graphically, what we are looking for is we want a wedge. So we want two prices where the quantities come out to be equal, and the prices are separated by exactly the tax, which in this case is two galleons. So we have a 2 galleon tax. We need these two prices to be separated by exactly 2. Okay, so let's just go through and calculate this thing. Maybe we'll start here. So this is post-tax. So here we need the price for the seller to be equal to the price for the buyer, but 2 greater. So we take the supply curve. So this is 2 plus 1/2 Q. And then we take the demand curve. So this is, this is the price for the buyer needs to be 2 greater. So the supply curve, we add 2 to it. Gives us, set this equal to the demand curve. So this is 20 minus 1/2 times Q. And then all we do now is solve for the quantity. So this is 4 plus Q. So we're going to add the Q's together, is equal to 20. And then Q in this case, again, is relatively straightforward. It's just 16. We'll call this Q tau. And put a nice little box around it. And then to find the two prices now, where before we could simply just write down one single price, here we need 2 of them. So to do this, there are a bunch of ways of doing it. But I would say the easiest is to take this quantity and plug it in both to the supply curve. Well, we plug it into the supply curve and then we add 2 to it. And that gives us the price for the buyer. So let's do that. So we have the supply curve. So the price for the seller is equal to 2 plus 1/2 times the quantity supplied. And we know what that is. It's going to be 16. And all we do is simplify this thing. So it's 2 plus 16 divided by 2 is 8. So the price for the seller is equal to 10. And then the price for the buyer must be 2 greater than this thing. So the price of the buyer must be equal to 12. And we can just check that the math we've done sort of works out, because the price in equilibrium is between these two things. Turns out it's exactly halfway in between. It doesn't always need to be that way, but in this case it is. But it will always be true that as you impose a tax, the price for the buyer will be higher than the original equilibrium price, and the price of the seller will be below the original equilibrium price. Okay, so we've imposed the tax. We know the prices beforehand and the prices and quantities after. So what we want to do is try to quantify welfare. So let's do a bit of welfare. So pre-tax, put in A, B, C, D, E, F. So welfare beforehand, we had consumer surplus was equal to A plus B plus C. And producer surplus, these are the only two measures. We had D plus E plus F. And then post-tax, let's put it down, we'll do it over here. We have consumer surplus is equal to A. The price of the buyer is PB. We have the demand curve, and then we have the quantity demanded. So the consumer surplus is just A. Producer surplus is just F. It's below the seller's price, inside the quantity supplied and above the supply curve. So we have F. Government revenue is this rectangle. It's for everything that we're imposing a tax on, how much are we taxing? So it's 2 times quantity tau. So it's B plus D. And then our deadweight loss is equal to C plus E. Okay, so we're going to actually calculate all of these things. So the welfare after we've imposed the tax. So let's do that. All right, so consumer surplus. This is equal to 1/2 height times base. So height in this case is the price of the buyer minus the vertical intercept of the demand curve. So this is 20 minus 20 minus 12, this thing. Okay. And 20 minus 12, and then we multiply it by Q, which is 16. Okay, so we're looking at this triangle, and we have the height, we have the base, and we divide it by 2. So this comes out to be 8, so 1/2 times 16 times 8, and this gives us 64. Okay, so there's our consumer surplus. We have our producer surplus, which is, we have a height, so 2 all the way up to PS. So this is 1/2 times PS, which we found here to be 10. Multiply that by 16. Okay, and then we can simplify this thing. So it's 8 times 8. So again, we get 64. Nice. So these things are still equal. And then government revenue is equal to it's the height of the rectangle. So it's 2 times the quantity, which is 16. So this thing comes out to be 32. And then deadweight loss is the area of this triangle. So we know what the height is. So 1/2, it's a triangle, so it's 1/2 times height. And then base is the difference between these two quantities. So it's 16. It's 18 minus 16. So the base is also 2. So the deadweight loss in this case is 2. Okay, so this is sort of a mathematical description of what's going on, but let's write out a bit of just some conclusions here. So we've imposed a tax, and quantity has gone down. So the tax lowered quantity, raised the buyer's price by 1, lowered the seller's price by 1, it generated some government revenue, and also produced some deadweight loss. Deadweight loss. Okay, so this is a nice description. There are other things we could do, like we didn't solve for consumer and producer surplus before the tax, which is something we definitely could do, but that's we'll maybe save that for another one. Okay, so that's nice. That's question 2. Let's move on to question 3. So let's do this in blue. Question 3. This is the, whoops, flue powder. Gosh, I love using flue powder. All right, so really saves on the commute time, you know. All right, so witches and wizards use flue powder to get around, but it's also associated with negative environmental effects, including air pollution. So the ministry's Bureau of Economic Analysis, which hopefully some of you will get jobs with, has estimated the externality to be 10 galleons. Okay, and then we have these 2 equations, and the ministry's hired us to design a policy that corrects the market failure. All right. So the first thing we'll do is set up a graph using the original equilibrium, or the original supply and demand, and solve for market equilibrium. So let's do that. All right, so on the vertical we have price, horizontal we have quantity, we have an upward sloping supply curve, we have a downward sloping demand curve, and we have our equilibrium, where neither buyer nor seller wishes to change their price. Okay. So we solve for this. So market. So we'll solve for Q star first. So we set P equal to P. So this is 100 minus 2Q is equal to Q. And this is 100 is equal to 3Q. So Q is equal to 100 over 3. We'll put a hat on this. So we know there's an externality. So we know the market solution is not going to correspond with the social planner solution. So we'll put a hat on this. And that looks like this thing. And then let's solve for price. So we plug this either into the supply or demand curve, but it turns out the supply curve is just way easier. So we get a P hat is equal to 100 over 3. So that's this thing. All right, very nice. Now, we have a negative externality. And what we want to do is, in step 2, we're calculating the social efficient quantity. So we know that the marginal social cost is higher because there's a negative externality. It's higher than the marginal cost curve. We also have marginal benefit equals marginal social benefit here. And our goal is to find this quantity. Some of you may be wondering why we don't find prices when we look at this this quantity. And the reason is that prices in this context, simply with a marginal social cost curve, without imposing a policy yet, it doesn't really make a lot of sense. We don't have a single price that makes this possible. In fact, when we talk about a tax, we'll talk about 2 prices. So we're just going to find Q star without reference to prices. Okay, so let's talk about, so the vertical intercept here is 10 galleons. So we'll find the social quantity. So to do this, we set MSB equal to MSC. MSB is just our demand curve. So this is 100 minus 2Q. MSC is our supply curve plus the externality. So this is our externality plus the supply curve, which is Q. And then we will solve. So we'll find quantity. This is 90 minus, whoops, is equal to 3Q. So then Q star is equal to 30. Okay? And this is just slightly smaller than this thing. Okay, very nice. So we found this. The next thing to do is to graph and calculate the deadweight loss. And then we don't need to discuss other welfare measures. So let's do this in black. So we know the deadweight loss will be above this interval. We're producing too much, and that's associated with extra costs that are not necessary. And so when we look for deadweight loss, we're always looking between the marginal social cost curve and the marginal social benefit curve. So we look above this interval, and then we find the marginal social benefit curve and the marginal social cost curve, and that forms a triangle, which gives us our deadweight loss. Okay, and so we're asked to calculate this thing. So deadweight loss is equal to the height of the deadweight loss. So it's 1/2 times height. We know the height because we know the vertical distance between MSC and MC. And that's 10, just the size of the externality. Okay, and then the base is just the difference between these two things. So this is 100 over 3 minus 30. So this is 5, let's do it down here, 5 times, this is 90 over 3, so this is 10 over 3. So this just comes out to be 50 over 3. All right, so that's the deadweight loss. The next step is to propose a policy intervention to fix the market failure. The policy, let's do this, it's a nice color, red. Policy is got a technical difficulty with the pen tip, is a tax. So we impose a tax equal to the externality. Okay, so this is the policy we'll use. So the tax is equal to 10. All right, and so the way we'll graph this is by essentially sliding a tax wedge in from the left until it gets stuck in between the supply curve and the demand curve. The other way of thinking about it is that we're just going to essentially overlay a tax, the supply curve with a tax on top of the MSC. So we're essentially adding an additional cost for sellers and raising the supply curve up until it sort of sits directly over top of the supply curve, the MSC curve. Either way we do it, the price for the buyer, PB, is here, and the price for the seller is here, PS. And we can find those relatively easily. All we do is we take Q star and we plug it into the supply curve, plug it into the demand curve, and that gives us the two quantities. We want to target this thing, and so we find the prices that make that happen. So the price for the buyer is equal, this pen, maybe we'll use a different color. Let's see. Let's use we'll just go with this. Price of the buyer is equal to 100 minus 2 times Q, which is 30. This thing is 100 minus 60, so the price for the buyer is equal to 40. And this thing, for sure, is above this price. This is like roughly 33, 34. So the price for the seller, we take this quantity, plug it into the supply curve, and that tells us how much sellers need to receive to produce the socially efficient quantity. And judging by the supply curve, we plug in 30, and that gives us a price for the seller of 30. And again, now you can see directly that these two things are different by exactly the value of the tax. Okay, so that's those first three questions. The last question is sort of a different type. This is a question about the intuition for deadweight loss. And so what we're wondering is which of the following best explains the intuition for a deadweight loss associated with a negative externality, like the one we just talked through. So let's just read through some of these options. The first one, the externality causes the market to produce too much of the good. So already we know this isn't right. A negative externality actually, too much of the good. Yeah, so that's okay. The second part of this question is that it leads to a surplus, which that is a red flag. So this is not it's not what happens. It's producing too much, but it's not actually a surplus. Okay, so the second one, the externality causes the market to produce too little of the good. So let's just examine what's going on here. So markets are producing more